Okay, so now the iOS. Okay, even though Cisco is known for their hardware, what really separates them is their software. Okay, their ease of syntax. Okay, even though Juniper's syntax is still amazing in its own, okay, Cisco's syntax is unique in its own as well. And this is what they're known for. We have what we call not networking folks, but Cisco folks. Okay, these are the people that will never touch another piece of equipment unless it's a Cisco device. This is the operating system that they know. Okay, an operating system's job is to give you an interface as it handles the actual hardware and makes the hardware do what it needs to do. You can't have hardware without software. Okay, and iOS from Cisco is called Internetwork Operating System. Okay, this operating system uses what's called a CLI. Okay, that CLI is an interface that you use to type in commands to turn things on, to turn things off, and to configure your device. Okay, now this is understanding the device, what we're talking about now, and without this, okay, you're not going to understand how your device is working. So it's important, all right, and it's crucial. A router and a switch, even though it's a different operating system on the hardware, it is nothing different than a computer. Okay, it still goes through a boot process. It still posts. Okay, it still does the things that needs to be done. So just keep that in mind. It's just a computer. If you have a computer background, okay, the hardware part is not going to be that much of an issue. Okay, all right, but you still need to learn where things are at and how it works. Okay, now just like a computer, all right, router and switches have RAM. Okay, in our router, okay, in our switch, this is where our tables are stored, our MAC address tables, our routing tables, okay? All right, a routing table is used to make forwarding decisions based on what interface the route needs to go. I'm sorry, what interface is assigned to a particular route, so the router knows where to send, what interface to send that traffic out to for that route destination. Okay, that's the best way I can explain it. All right, now when the router boots or the switch boots, okay, it has what we call a startup config, meaning that once you turn the power off on these devices, whatever's in memory is gone, is wiped out. It doesn't have power. It can't store anything without power. That's why we have hard drives. Okay, all right, the hard drive is there to actually move data from the hard drive into RAM as you're booting Windows. Even though these devices don't have hard drives for in that sense, okay, all right, it has what we call ROM, which is read-only memory. All right, that starts the operating system. Okay, but there is a certain config for that actual device that is used to start up the device. Okay, when you find when the configs from the start config is started, okay, it is put in what is called the running config. This running config is what's in memory. Okay, now the running config, okay, every time you make changes to the running config that's in RAM, if you do not save it, okay, because once you save it, it copies your running config to your startup config. It overwrites it. All right, so your startup config goes into your running config. So whatever's in your startup config, that's how your device is configured. All right, in the running config is where you make changes. Okay, as the device is running, every change you make is to the running config in memory and RAM. However, if you do not save it, okay, moving it from the running config to the startup config, when that thing power cycles, and hell, that could be years later, everything that you had configured from the last time it booted from the startup config, every change you made to the running config, and you never saved it, okay, is gone. All right, meaning you have to go back and make all those changes again and all those configurations again and save it to get it to the startup config. But once you save it, everything you configured and how your device is running is going to return when it power cycles. Now there's a difference of rebooting and power cycling, okay? But they still do the same thing. It kills whatever's in memory when you reboot. It kills whatever in memory whenever you power cycle, taking the power out of from it and bringing it back in, okay? All right? You still lose whatever's in RAM, meaning you lose your running config. If it's not in the startup config, your router is not configured for what you wanted to configure for if you had it in the running config and did not save it. So always save your configs. So next time, if it reboots, okay, it could even be a storm. Power cuts off, power comes back on, and now your router or switch is not configured nowhere near the way it was, and traffic doesn't move because you forgot to save. Okay? Now, what is NVRAM? This is where you have permanent storage. Okay? All right? This is where you can save files to, copy new versions of the operating system to. You can save your configs to it. You can save text files to it. You can save your VLAN information in there. Okay, that is permanent. Okay, so every time it power cycles, that data, whatever you have in the VRAM, okay, in the NVRAM, that is, all right, it stays. Okay, what is flash? Flash, okay, is the same thing, okay, as NVRAM, except it's a hard physical device, which NVRAM is too, but NVRAM is inside your router in your switch, and if you were able to take it out, okay, meaning that it's not soldered to the board, or you would have to actually open up the device, where a flash card is something that you can slide into a module. Okay, all right. Now again, you have to understand something. During the boot process, not only is the start config is started, but remember, every time you power cycle, everything in RAM is gone. Okay, so what does that mean? That means every time it boots, it starts from nothing. Okay, and the first thing it has to do before it can even pull the start file, a startup config, and bring it into running config is it has to load some type of operating system. Okay, all right. And that is where your operating system is stored, as an NVRAM or on your flash. Okay, that starts to get loaded every time you power cycle or reboot the device. That brings it to memory, and now that operating system, as it gets to a certain level of booting or installing, because technically you're installing in the RAM, all right, it will now, one of the process of the operating system is to go check for the startup config and pull it and bring it into the running config, bring it back in, bring it into RAM. Okay, so that's nice. We have two places. Okay, we have the storage, we have the startup config, which is on a device, somewhere on a device. Okay, all right, and then you have a NVRAM and flash where you can store things that you need to store. Okay, as far as the operating system. All right, now read-only memory. Okay, this read-only memory is used for, okay, so if you ever do emulations like I do for like Nintendo and things like that, we call them ROMs. Okay, it's those little circuit boards that have little modules on there where the game is stored. Okay, all right, and we call them cartridges, right? They're nice and big, but the ROM itself is very tiny. All right, and when you go to an arcade, think about it. Your circuit board is not that big at all, and that huge ass machine is mainly space. Seriously, okay? It's to look like you are, playing with something that's amazing and complex, where the game might be small and the circuit board might be small, and the complexity of the coding, okay, to create the actual game might be complex, okay? But that thing is not filled with circuit boards, all right? It's filled with air, with space, all right? And those read-only modules, okay, is where we will store our video game. Read-only means we can't make changes, okay? Random access memory, which is your RAM, okay, we can go in there and make changes to our running config, all right? Make choices on how our operating system operates, okay? Our features being turned on and off. Where ROM, no, you have nothing, no choice, okay? This is where your post is stored. Remember, your device is nothing in the beginning every time it powers on. Okay, so something has to be initialized to start making things happen. Okay, and in ROM, that's where your post, okay, post means power on self test. All right, again, if you're for computer error, all this makes sense to you. Okay, all right, this will allow your system to go through several checks. Okay, load the BIOS. Okay, check the BIOS. The BIOS is going to be in ROM. Okay, all right, and go through and check your memory, your hard drive, your controllers, things of that nature. Okay, if you don't pass post, we're not booting. Okay, we're done. All right, and it's your time, and it's your time to actually go through and troubleshoot and figure out what's going on. All right, okay. There's also a mini OS that's on there. Okay, and that mini OS is called Ramen. And if your device ever boots into ramen mode instead of booting to a command line prompt, okay, all right, because that's what CLI stands for. Sorry, I never told you that. Okay, it is command line interface. It's an interface because you're interacting with it. Okay, the user is, and it's a command line because it is a prompt for you to put commands. Okay, so this is your prompt. Okay, this is your CLI. This is a switch we're logged into. Notice I named it home switch. Okay, I could actually go in here and change the name if I want to. See? Okay. All right. Now we're going to change it back. I had something I was going to say, but I lost it. All my devices are called home in the beginning. Okay. All right. Let me know where I'm at, just in case because originally I had 5108 UCS servers, a UCS chassis, and I'm going to be getting another one too. And that will be my data center. Okay, so instead of having home, it'll have home underscore DC underscore and whatever the name of the machine is. Does that make sense? Okay. All right, and that's us saving our configs. It says building configuration. All right, that's how we save configs in Cisco. Okay, all right, and you'll get to learn the syntax when we get deeper involved in it. Okay, so config.txt. Let's go take a look at our flash here. Okay, these are where things are stored. Here is my operating system. Check that out. Okay, all right, here's my VLAN information. Okay, without this, your VLANs won't load. Let's say we created VLANs 1, 2, 3, and 4, 5. Okay, once this is deleted off this flash drive, the switch has no idea to know what VLANs you have, so you have none. Okay, all right, here's a config.txt file, all right, and here is your private config.txt file. Now, okay, so this flash, okay, is your hard memory. Okay, we could actually do a show version, okay, and look at this version of software, which is 12.2-46, okay, and this is your first command for you to know exactly what operating system we're running and where it's located. Okay, that flash could also mean disk. Okay, all right, it could be disk 0, disk 1. All right, okay, I mean, you know, telling you that you have a hard drive in that bad boy, where this is actually flash. Okay, all right, it gives you some more information. Okay, like the assembly number, okay, the part number, the serial number, okay, which normally really isn't the real serial number, okay, all right, but sometimes it is. So let's go in here and let's say show inventory. Your second command for you to know, all right, and that is your real serial number, and go back up, and as you see, they are different. AOUGFK. Okay, that's where you get your real serial number from. So if you call Cisco and they ask you for a serial number and you give them this is the serial number for your motherboard, not your actual chassis. And you also got to understand, like this switch. Okay, let's go take a look at the switch here. I think it's here. No, maybe it is here. Yes. Okay. All right. This device, if you took it apart, inside you will have a motherboard. Okay. On that motherboard, you will have plastic, clear things that will come up and elbow into these ports. Okay. All right. Those will carry the light from the port, or the electrical signal from the port, to the actual motherboard, into the controller or into the queues, and that's where it needs to go. The queues are logical, not physical. We're talking about physical. So, you know, into the board, okay, into the controller. Now, or the channel that takes us to the controller. Now, okay, these are RJ45 connectors. These are fiber. Now, take this apart. You will see that motherboard. On there will be your flash that you can actually replace and upgrade. Okay, let's say you run out of space. All right, okay, important. All right, because when you do a show version, all right, where is it? Where is it? It's show flash. That's why. Okay, all right, there is your free space. Okay, and if that starts to creep down to almost nothing, okay, you're going to either put a separate flash card in there, meaning that you have another module to add a second flash card, okay, which in some cases you don't, some cases you do, all right, depending on the model and the feature of that model. And I mean, because you can have a second flash module, but it's not functional. It's not hooked up. Okay. All right. Because these things come off of a assembly line, and whatever model that you have may only support one flash card, but you have two slots, thinking that you have the ability to add a different slot, and you don't. All right. Now, you can actually take that flash, okay, copy it over to a new flash that's bigger, right? Okay, and take that flash drive, take that flash card, put it back into this switch or this router, and you're good to go. Now you got enough more space to add more files. Okay, sometimes you'll have multiple iOSs on there because when you upgrade to an iOS, you don't want to delete this one just yet. All right, because you need to make sure that the new one that you put on there is stable, that it's not causing you issues, that the features that you need to run in your organization is there. So we keep this on there for a period of time. Maybe never take it off, just in case we got to do a rollback. Rollback meaning that we're going to actually go back to our original config. Making a operating system upgrade is a change on our network. Okay. All right. So, all right. That's what you see when you open up. But you physically have to go in there and take the flash out to put new flash in there. All right. You got fans in there as well. Okay. And if we go back here and say show environment, our next this doesn't have that command. Okay. All right. So show environment is another command to use. All right. And unless that command actually is show environment. No. Yes, it is. Show environment fan. Fan is okay. Okay. Let's take a look at our power. Okay. All right. Our power is good. Let's take a look at all. Okay. All right. Status is not present. I wonder why. Let's take a look at our temperatures. Let's see if that comes up. Temperature is okay. Okay. All right. So it's not giving you stats. Okay. Let's do RPS. And that says not present. Okay. So, so these commands are commands you need to know to manage your device. This is what your job as a network admin, network engineer is, to know how to get information out of these devices. That's what your show commands are for. Okay? All right? Now, your console port. Okay? Okay, all right. Notice it says access to CLI via PuTTY, which is an application using a console connection on your device. Okay, this is how you access your device. Without a console cable, you cannot initially make any changes or configurations to that device. Out of the box, okay, you can't even telnet to it, all right, or SSH to it, all right? You need a console cable to access your device. Now, the thing about this is, all right, it uses a communication port. Now, I'm going to go on my device manager. Now, if you're a computer person, this all, like I said, this all makes sense to you. Here are your ports right here in device manager. Okay. All right. They're called COM ports, communication ports. Real COM ports, okay, are circuitry, okay, that is on the actual motherboard. And what you need is to plug something into those pins, okay, to give you a console port availability. Okay. All right. So we're going to go here and say COM port. All right. Oh, I'm sorry. I just had, well, that's even better. Okay. This is a communication port. This is a communication port. Okay. All right. And This is what a COM port looks like when you actually plug it in, okay, on the board. All right, it'll just be this piece here. Okay, this is a plate. All up here is a plate where you will slide it through the plate. All right, so you can have access to it outside of the computer, meaning you don't have to go into the computer where the motherboard's at to actually plug it in. So that's what this plate is for. Now, this is, you have this hard piece here, which is your adapter, and then you will have a flimsy cable that you plug in on the pins of the actual motherboard, and now you have a COM port. Okay, now today on an average, because of USB, all right, having a communication port on your motherboard is slim to none. However, do not be mistaken that the circuitry for COM ports is still there on your motherboard, whether they are pinned out or not. Okay, let's say there's, and you'll see it on the board, it'll literally say COM port, okay, but there's no pins on there. All right, that means you got a motherboard that does not support COM ports. The circuitry is there for the COM ports, okay, all right. If you're savvy, you could solder wire, you could cut the COM port cable and solder the wires onto the pins, okay, that are on the board, or the circles or the placements of the actual circuitry, okay, all right. And when you order a laptop, you have to specifically request a COM port, okay? And that's exactly what I do. Now, when you get work laptops, you're stuck with whatever you're stuck with. Okay, you can't get a COM port. That's why you buy this bad boy right here. This is a USB to COM port. That's why, because this computer here that we're on, my computer, does not have physical COM ports. Okay, but in Device Manager, you see them because, where's Device Manager? Okay, because, all right, this is a, see that? Serial over Bluetooth link. Never seen that before. Okay, however, it will be a USB to serial adapter. All right, which this is not it either. Since mine's not plugged in. Matter of fact, where is it? Hold on for 1 second. I'm gonna take my earphones off. So you're gonna hear silence here for a second. All right, hang on. I found it. Okay, now what I have is a USB to serial and and console cable all in one. And that's not normally what you're going to deal with or interact with. This is just a COM port, okay? USB to COM port. That gives you a COM port on your computer, okay? From there, you need what's called a console cable. All right, and for Cisco, this is what I have right here. I mean, guys, that's perfect. I mean, it came right up. Okay, this is what I have in my hand right now. All right, here is your USB to console port, and the cable is hardwired into it. Okay, this is what you're normally going to see and normally going to have as a console cable. All right, For Cisco, they're always blue. And the thing is, if you ever need to make these cables, okay, for whatever reason, all right, and you go out and you get one of these devices and you have to, wire them in, meaning that it's going to be able to take apart, right? Okay. I don't see any ones that, okay, something like this, right? All right. But that's not what I'm talking about. And I don't see, yeah, here we go, right here. This is it. This comes apart, okay? All right? This comes apart. All right, now here, this is a RJ45 2-COM port, okay? All right, which is what you're going to need if you have a COM port and you need to plug in an RJ45. If that is what you're going to do, okay, remember we talked about crossover cables. Well, this is what's called a rollover cable, meaning that pin 1 on one side goes to pin 9 on, or pin 8 on the other side. 2 goes to 7, 3 goes to 6, 4 go, you see my point? It rolls over. It's backwards. Okay? Otherwise, you're not going to have communication. The pinouts are going to be wrong if you ever have to do that. Now, there are devices that only has this part on this side, okay, and have wires coming off of them. All right, that's where you will physically be wiring it with the with a Cat 5 or Cat 6 cable, okay? All right, but then again, you need to know which one is pin 1, all right? And that can easily be done by looking it up on the internet. You got to find out which one pin 1 and make sure that that pin, okay, pin 1, which I'm assuming is this one up here, upper left, that pin 1 must go, okay, to pin 8 on the other side of your cable. All right, so you got to keep that in mind. All right, so that will be a rollover cable. It's the opposite on the other side. Then you will have communication. If you just plug in, okay, if you just plug in a cable, an RJ45 cable, it's not going to work. However, you have, look at this, because I have these two. Right here, okay? All right, this is a rollover adapter, meaning that you just have a straight through RJ45 connector, okay? All right, you put this on one side and that rolls the cable over, and that will allow you to console into your devices. All right, so let's go back to my device manager, and I'm gonna plug in my USB to serial adapter, which you saw that was all connected in one. Let's see, device manager refresh, okay, and that is my COM port. Now, this cable is not plugged into the switch, and I can't get to it because I have books on it. All right, so also understand your scenario, your parameters, okay. Cisco terminal, because that's what it is. It's a terminal. Terminal settings. Okay, or you can say Cisco console settings. Okay, and here are your settings right here. As you can see, all right, because mine says COM4, meaning that on the older computers, you can have multiple COM ports, okay? And you must, if you're only plugged into COM1, you can only communicate with COM1. Communication ports were used for scanners. They were used for barcode readers. They were used for printers. If that was the one that, if you were using that particular COM port, a COM port can be used for whatever is needed, okay? Now, obviously, you got to have a COM port in your actual device, which we do on our Cisco devices. Okay, so you got to make sure you have the right COM number, whether it is hard-coded on the board or you're using a USB. That's why you go into Device Manager to find out what your COM port is. All right, notice it's COM4. It didn't even pick 1 or 2. It went right to COM4, and it usually does that because obviously 1 and 2 are 9 times out of 10 is going to be assigned hard-coded for the board. And their software does not know if you have COM ports on your board or not. All right, that's why they start with COM4 or COM3 or whatever. Okay, your speed band, okay, your data bits, your parity, okay, and your flow control. All right, normally the speed bond is 9,600, not 11,000, not 115,000. Okay, all right. You can make it. You can make it that, but you got to understand how queues work, logical queues. Okay, every port has a queue where data goes into that queue. Okay, and is stored. Okay, before it's processed. Meaning that every command, every keystroke that I make, that data comes from my computer through the COM port into the COM port of the device, into the queue, okay, and gets processed. Now, if my speed on the COM port of the Cisco device is 9600, and I set my speed on my terminal software, okay, this particular software is called PuTTY, very common use, okay, I use Secure CRT, all right, but, you know, and most likely when you start getting used to that or use that software, most likely you'll get to that yourself and you'll pay for it out of your own pocket, whether the company uses it or not, all right, so, okay, especially if you're an engineer, this is just, you know, this is just what we use, Secure CRT. Now, oh, what was I saying? Where was I going with this? Oh, okay. All right. If I set my speed onto the software at 115,000, okay, and my speed on the Cisco device is 9600, there is no communication. As a matter of fact, okay, what's going to happen is too much data is going to go to that port and that queue is going to get it filled up so fast because it's running at 9600 and you're pushing data into it at 115,000 bond rate. It's too fast. Okay? And it can't keep up. Now, listen to this carefully. You must be on the exact same speed in order for communication to work. Okay? Us telnetting to a device, like I did here, okay, that's logical. All right? So there's no speeds on that concept except the wire speed. All right? So, but that's a logical interface that I'm communicating with the device on, giving me access. It's not console access. Okay? It's a logical session that's giving me access to the device for management purposes. Now, if I set 9600 on the Cisco device and I set my speed to 9601, okay, on this software, I still can't communicate. It must be the same. The second you change the bond rate, you're speaking a different language. It must be the same. And by now, you should realize how perfect a computer must be. Whether it's a 1 or a 0, the ones and zeros must be in the correct order and be specific in order for your action to work correctly. Same thing here. You got to be the same bond rate. Meaning that I'll have to go into my Cisco device, okay? If I wanted to change the speed to 115,000, I have to go into the speed, into the console port configuration and change the bond rate, okay, to match with the software I'm using, okay? By default, it's 9600. Now, why would I want to change it to a higher speed? Well, let's say you got lines and lines and lines of config, and what ends up happening is you copy the whole thing and you paste it in there. And then it starts, line by line, it starts actually getting pasted in, and all of a sudden you get a bunch of garbage. It's not taking the commands, because what's happening is the queue is getting filled up, and the processing of that information is not it's not moving fast enough to empty the queue out to give the queue more space. So your commands start to fail. And that's because your queue is not fast enough. So up the speed to 115,000, next thing you know, you can, paste in that whole, a whole page, okay? A notepad page, if not several pages at a time, because the speed of your bond rate's a lot faster, the queue's a lot faster, and it can process that data a lot faster before you can fill it up due to the speed. Okay? All right? Important tip notes that are needed for learning how to access your equipment. Okay? All right, next video we're going to talk about the actual boot process. This video has been long enough, and always remember, be strong, be determined, be Cisco.